Welcome back students. Now in this part I'll be telling you about the isomerism. Isomerism exists as a structural one and the stereo one. In the structural one I'll be telling you about the parts like functional isomerism. They may depend upon the position also, so position isomerism. And for the stereo isomerism we have optical isomerism and the geometrical isomerism. The optical isomerism I am going to tell you with the help of a video, kind of a gaming video. So let's see it. Let's proceed. Next guys, we'll be talking about isomerism, okay? Isomerism. So you will be seeing that I have same formula but I have different forms of it, okay? I have different forms of it, and that is what I mean by isomerism. That's what I mean by isomerism. And this isomerism thing, it exists in two ways. Either it can be structural one or the stereo one. Structural one or the stereo one. So if I talk about the structural one, then I have chain isomerism, position isomerism, functional isomerism and metamerism. And stereo isomerism means what? You have geometrical, cis trans isomerism, and you have D or L type optical isomerism. We'll see soon. So here we first study the structural isomerism. First is chain isomerism. So when two or more compounds, they have similar molecular formula but different carbon skeleton. What is the word here? Carbon skeleton. Then I say that is what is my chain isomer. Okay, chain, like this formula. You have this pentane, okay, normal pentane, okay. I can also treat it like a tertiary butyl, like this way. The formula will be the same. I can also treat it like isopentane, 2-methyl butane. The formula is the same. You can check the number of carbon atoms and the hydrogen atoms. It will be the same. But existence in the different types, different carbon skeleton. You can see that carbon skeleton, it changed. Here you have a different carbon skeleton. Here you have something different. Here also something different, but the formula is same. Molecular formula is same. It's of pentane, right? C5H12. You can check the number of carbon and hydrogen atoms. So this is what I mean by chain isomerism. Next is the position isomerism. So position isomerism, when do we say that I have position isomerism? When they have functional group on different carbon skeleton. Okay, or the substituent atom on a different carbon atom, like this. If I have OH here, okay, and I have OH here, so the functional group is at different positions. That's why this is known as position isomerism. Position isomerism. If I were to name this, okay, if I were to name this, then it will be named in one ol, right, and this will be 2 ol. Means the second group I will be having that ol. Second number. Then functional isomerism. How come the functional isomerism arise? See, the formula will remain the same. Now what will happen? The functional group will change. Okay. So formula remains the same but the functional group changes with the functional group. Then we say that it is my functional isomerism. Then group isomerism. It's like this. You have CH3, CO, CH3, right? Here you have CH3, CH2, CO, CHO. So group means it will get converted from this side to that side. So here you have aldehyde and ketone, right? This is a ketone. This is a aldehyde. So that we say group isomerism or the metamerism. Okay, metamerism. So metamerism also arises due to different alkyl chains on the other side of the function group. So here I have different alkyl chains, right? If you check this functional group, I have 2 CH3 attached to it. Then I have C2H5 and H attached to it. So that's why metamerism is existing between those two. Aldo ketone. Okay, aldo keto we say. So this is about the structural isomerism, guys. Structural isomerism. Next comes the stereoisomers. Now stereoisomers are the very very interesting topic. most of the students like stereoisomers a lot because of the presence of something which is known as chiral center. Chiral center. By chiral center, what do you mean? I mean that a carbon atom which is unsymmetrical. Carbon atom which is unsymmetrical. That is what is my chiral carbon atom, and that gives me the property to get my stereoisomers. So stereoisomers, they have the same constitution, but their sequence of the covalent bond, it differ. Okay, it differ in the 3D space. We say in the 3D space it differ. So these are categorized into the geometrical and the optical. Geometrical is what? It's just like trans and cis. If suppose I have X here and Y, Z, Z. So this is a cis isomer. If I have X here and Y, Z, Z. So this is a trans. This is cis, this is trans, the compound. Next, the optical isomerism thing, that and the stereoisomerism thing, which is your optical one. So that I am going to teach you by a video, which will be very, very interesting. This is a very, very good quality animated video. So you will better know what is actually happening. And what do I mean by chiral center? What do we mean by enantiomers? So make a keyword here, okay? Enantiomers. Then your racemic mixture, chiral center. Make a note of it from the video. So here is the video, guys. Now as I am moving, I want a tetrahedral structure. So that is my carbon which is attached to the 4 atoms, and I want a chiral center. So chiral means what? Chiral means unsymmetrical. And so all those 4 are different group attached. And now I want a mirror image of it. So I brought a mirror, okay, I brought a mirror in front of it, and you can see that I have also got the mirror image. I have also got the mirror image to it. Yeah. Then this mirror image is your enantiomer, guys. This mirror image is your enantiomer. Okay. Why I am saying it is enantiomer? Because they are non-superimposable, which you will learn now. What is superimposable and non-superimposable? So suppose if I have this molecule, okay, I make a copy of it by my advanced duplicator, and when I copied it, and if I try to superimpose this structure, okay, over the previous one, as this is a copy, this is what? This is your congruent, okay, this is congruent structure, this will get fit easily, exactly, right? So this is not enantiomer, this is not an enantiomer, this is not a mirror image. What are enantiomers? Enantiomers are the non-superimposable mirror images. So what I will try to do, I will just change the position, okay, I will make that yellow ball green, okay, and that green ball yellow. Now they are mirror images, right? Now they are mirror images, and these are what we say enantiomers. If I now try to superimpose this one over this, it will never get superimposed. Whether you rotate it in any direction, it will never get superimposed. So that is what do I mean by enantiomers. Enantiomers, guys. Okay, that is what do we mean by enantiomers. Non-superimposable mirror images. Even if I try a lot of it, then what will happen? It will be totally frustrated, burst up. Oh God. Yeah. So this is what do I mean by enantiomers. Enantiomers. Non-superimposable mirror images, and they show the optical activity. Now, if I combine, if I just copy this structure, okay, many times, and if I copy the same mirror image of this structure many times, and if I mix them, then I have set of enantiomers. Then I will be having what? I will be having the set of enantiomers, and that set of enantiomers is known as what? Racemic mixture. Set of enantiomers is known as racemic mixture. So here I am collecting them, okay, one of the first type, another of the mirror image type, and I have mixed them up, I have mingled them up. So they are what? They are my racemic mixture. So that's what I say, a racemic mixture, a racemic mixture. So this is about the stereoisomer, guys, stereoisomers. So I hope you like the stereoisomers, right? With that animated video. So students, in this part, I told you about isomerism, various type of isomerism, position isomerism, structural isomerism, functional isomerism and all. Also, we deal with the stereoisomers, right? The optical and the geometrical isomerism, the cis-trans ones. And I hope you must have enjoyed that video game, right? The Counter-Strike game type of thing. Yeah, so that will be creating your basis, how to understand my enantiomers, the racemic mixture and all. Next, I will be talking you about various reactions, various organic chemistry reactions. Because just like in inorganic chemistry, here in organic chemistry we have some mechanisms how do a chemical organic reaction takes place. So stay tuned with me for that.